All right, so today we are talking about ionic bonds. Ionic bonds are going to be formed between oppositely charged ions. Remember, opposites attract. So a positive ion is going to be attracted to a negative ion. Positive ions are cations, and they are typically metals. That's, again, where your periodic table comes in handy. Anions are nonmetals. So ionic bonds are going to be between a metal and a nonmetal. Okay, so metallic bonds are two metals, covalent two nonmetals, ionic two metals. Electrons are going to be transferred from one atom to the other. So that's going to leave one atom with a negative charge and one atom with a positive charge. These reactions or compounds are always exothermic, which means they give off heat or energy when they are created. They are relatively strong, which means they require a large amount of energy to break apart, which means they have a high melting point because you have to break bonds in order to melt things and break bonds in order to move things from a liquid to a gas, which is boiling point. They make hard, brittle solids at room temperature. They do not conduct electricity in a solid state. However, they are called electrolytes when they are dissolved in water. And that is what makes up your Gatorade and your Powerade, these electrolytes. And they do conduct a little bit of electricity when they are in an aqueous solution. All right, ionic bonds tend to form crystal lattice structures when they're solid. And so this is sort of a little bit about how that would look. Remember, metals were in a very sort of solid row type structure, and this is more cube type structure. All right, so here's a checkpoint. Before we get to the checkpoint, I would like to have you watch this little video reminder of ionic bonding and the periodic table.
In this video, we'll talk about how to find the charge of ions on the periodic table. So there's a regular pattern, and this is really useful to remember in chemistry for formula and naming of compounds, net ionic equations. Many things rely on you quickly being able to figure out the charge on ions here from the periodic table. So here's the pattern. In group 1, these are 1 plus. That means all of these will have an ionic charge of 1 plus when they form ions or bond with other compounds. Group 2, 2 plus. We skip all of these. These are the transition metals here, and we skip those because they can have variable charges. We come over here to group 13, sometimes called 3A, 3 plus. And then for carbon, it's often considered to be 4 plus or 4 minus. Then we go down. 3 minus for nitrogen, that's group 15. We go 2 minus, 1 minus, and then the noble gases is 0. So you see the pattern. 1, 2, 3, 4 plus or minus, then 3 minus, 2 minus, 1 minus, 0. You can kind of think of it this way. Group 1 is 1 plus, we go 2 plus, skip the transition metals, 3 plus, 4 plus or minus, 3 minus, 2 minus, 1 minus, 0. It's kind of like a mountain there. That's the trend for ionic charge. But this is a general trend. Let's look at a little more detailed periodic table with ionic charge listed. So these are the specific ionic charges on the periodic table that you can expect. All of these in group 1 are 1 plus, they form 1 plus ions. Group 2, 2 plus, we skip the transition metals, and there are also a number of elements over here that have variable charges. So we go 3 plus for the aluminum here and the gallium. We don't consider any of these really to have ionic charge. 3 minus, 2 minus, 1 minus, and 0. You'll note that zinc should be 2 plus and cadmium will be 2 plus, always. And then silver will always be 1 plus. And you can see a mistake here. When we write ionic charge, it's always the number and then the sign. So this should be 2 plus and this should be 1 plus. So this table here is a little more detailed, and you get the idea that a lot of the elements we don't really know the ionic charges for. But these are the ones that we use quite a bit in chemistry. We also have ions that aren't listed on the periodic table. They're made up of more than one type of atom. These are called polyatomic ions, like NH4 plus or SO4 2 minus. Your teacher often will let you use this table on a test, but some teachers do want you to memorize it, so check with your instructor. So in addition to the ions on the periodic table, we have these polyatomic ions, which probably aren't a bad idea to memorize some of the major ones.
Okay, so that should give you a better idea of the charges for these elements and what these might form. So pause the video and answer those questions yourself before moving on. Okay, coming back, let's look at carbon dioxide. If you look at carbon and you look at oxygen, you're going to see that they're both nonmetals. Therefore, that is a covalent bond. If you look at potassium and iodine, you'll see that iodine is a nonmetal, but potassium is a metal, so that is an ionic bond. All bonds can be solid at room temperature, but only covalent bonds can be liquid at room temperature. All right, what charge ion do these elements form? Hopefully you were able to use the periodic table to figure this out. Aluminum is going to give up 3 electrons, so it will be a 3 plus. Fluorine is going to accept 1 electron, so it will be a 1 minus. Sodium is going to give up 1 electron, that will be a 1 plus. Oxygen will typically give up 2 electrons and be a 2 minus, and nitrogen will typically give up 3 electrons and be a 3 minus. Typically, carbon is interesting because carbon's not on here, but carbon's interesting because it can give up 4 electrons, it can keep 4 electrons, it can also covalently bond with 4 different electrons. So carbon's kind of a wild card. And then if you look at calcium, calcium is a plus, or 2 plus, which means it's going to give up 2 electrons. All right, hopefully you got those correct, and let's move on. Now, we are going to talk about electronegativity. So this is how strongly atoms attract the electrons to themselves. The higher the electronegativity, which I'm abbreviating EN, the stronger the pull that the atom has for an electron. So it's like a tug of war for an electron. And this happens a lot in covalent bonds, especially. You will have one atom that pulls an electron closer to it, leaving, so it's like 2 toddlers that don't share nicely. One toddler is bigger, and so will pull the toy closer to themselves and try and play with it without actually doing the real sharing, right? So that's kind of how that will work. Differences in electronegativity determine whether a bond will be classified as a covalent, nonpolar, polar, or ionic. So this is the trends of electronegativity. So again, your periodic table, you got to know it. We increase across groups. So going from the left to the right, we increase, and then we decrease going down periods. Okay, so electronegativity increases going this way, decreases going this way. Why do we care? Well, we care because that's going to tell us whether or not the bond is a pure covalent bond, which means everybody is sharing electrons equally and there is no change in electronegativity. A small change, or again, no change, or very little change, like 0.03 or 0.3 here, you're going to see a non-polar covalent bond. This means that there's no real charge on either end. Okay, so pure covalent and non-polar covalent are really not going to have much of a charge at all. Or if not zero charge, very, very small charge. So they are not going to interact with other molecules in a way that which they'll be very thirsty for bonding. They really don't care about bonding. They're happy being their little covalent cells sharing their electrons relatively equally. Now, when we start getting into the greedy toddler, pulling the electron closer to it, we become polar covalent. That means we are sharing electrons unequally. And ionic is when we completely give up an electron. And when we completely give up an electron, that means the difference between the electronegativity of the two atoms is so great that the electron is just completely pulled to the other ion. And we'll see examples of that in a minute. All right, so here are definitions. Pure covalent, neither atom in the bond has a strong attraction other than the other for electrons. So if we're doing tug of war analogy, this is where both teams are pulling evenly and the little bandana in the middle doesn't move. Okay, nonpolar is the electrons are shared fairly equally. There might be a slight difference. So like maybe one team might be pulling it a little bit on closer to their side, but not enough to like win the game of tug of war, right? Polar covalent is basically there's going to be a slightly positive charge on one side and a slightly negative charge on the other side, meaning the electron, in this case, the little bandana in the middle, is going to be pulled definitely to one side or the other. And then ionic is when basically one of the molecules wins the tug of war and the electron completely goes over to the other side. So you have got to memorize these definitions. All right, that is the end of our conversation on ionic bonds.